Yes, class. Am I audible? Good evening. All are present. Maha, Aisha, Iram. Fine. So in the last class, we had completed motion under gravity. So what was the value of acceleration due to gravity, Aisha? Acceleration due to gravity. There was a constant value of acceleration due to gravity. What was
9.8
meter per second squared? Exactly. Please add the units as well when you're writing. So 9.8 meter per second squared. What is the direction of gravitational force, Aram? Gravity, acceleration due to gravity. What's the direction of it?
Negative.
Not negative, it's downwards, and it's up to you. See, if you choose the sign convention, downwards is positive, then acceleration due to gravity becomes positive. Direction is downwards, so it's up to you. If your sign convention says that upwards is negative and downwards is positive, so for you acceleration due to gravity will be plus 9.8 meter per second square. So that completely depends on you. As I was saying, in the sign convention you have the full liberty, whatever direction you can choose. Like in this question, the question that we did for the simultaneous balls, when both the balls were thrown simultaneously, one from the top with one from the below portion. So what happened? For all the downwards forces or velocities which were acting, what did we do? We considered it as negative. This was my condition that I took. All right, this was my condition. I could have chosen downwards as positive and upwards as negative. That depends on the person. You people can have different answers. That's why I was saying, whenever you are writing all these, because in relative velocity also, that we'll start in today's class, sign convention will be important. If you take left as positive, right becomes negative. For you, let's say Maha, for you upwards is positive, for Aisha upwards is negative. So both of you, if you're getting the same magnitude, it can happen that if you both have the same magnitude, the question's answer will be correct. It's just that sign convention will make it differ. So just don't forget to add the sign convention. The rest of the things we had discussed, and this topic got end. So any doubts from the last class, ask me. Then I'll start with relative velocity. Any doubts, class? Clear? All right. Now, relative velocity is an important topic. Relative velocity, you will be able to understand. See, in relative velocity, relative means what? One thing is known as absolute. Other thing is known as relative. Absolute means if I say Aram has scored 95 out of 100. For example, if I say Aram has scored 95 out of 100. That's our absolute score. If I say Aram's highest marks or the highest marks in physics is 95, which has been scored by Aram, then it becomes relative when you're talking with respect to something else, when you're comparing it with another quantity. Now, relative velocity in one dimension you have, in two dimensions you have. Obviously, relative velocity in 2D we'll see when we'll do projectile motion. Right now, we'll focus on relative velocity in 1D. So we'll start with relative velocity in 1D. Now, let's say a car is there. This is car A. Fine. This car A is moving. Let's say the velocity of this car A is 10 meter per second. So this is the absolute velocity of this car. I'm not comparing it with any other car. The velocity of any other vehicle is not being mentioned. So this is the absolute velocity. Now, how do I get involved with the relative velocities concept? Let's say I have another car. Another car is present, car B is present, which is, let's say, moving with 3 meter per second. It's moving slower than car. And a person is there who is standing on the ground. These three are the conditions. The person who is standing on the ground is at rest. So remember initial classes, I think that was missed by Maha and Fatima. But when we were discussing, I think Aram and Aisha must be remembering, we discussed the terms like rest, motion, and all these terms. For one thing, if a person is sitting in train, the person's companion or the person's, another person who is sitting around in front of him, he will look at it rest. But if it's the same person looks from the railway station view when the whole train is moving, it will appear that the passenger who is sitting inside the train is also moving. But for the passengers who are already inside the train, for them it appears that everybody is at rest, only the train is moving. So there comes the term and the concept of relative velocity. Now, if these are the conditions, let's say VA, it is the relative, it's the not relative, it's the velocity. So this person is there on ground. He observes car A moving with 10 meter per second. So this 10 meter per second, so this is the absolute velocity. What is meant by absolute velocity? This is the velocity of car A. Actual velocity of car A with respect to observer on ground. Fine. Now, even if an observer is not present on the ground, it doesn't mean your concept of velocities will get changed. You will assume that if a person was standing on the ground, the person would see the car moving in this manner. So this is it. Now, VB becomes what? VB becomes velocity of car B with respect to observer. So VB is the velocity of car B with respect to observer on ground. That's the condition for car B. Now for observer in B, car B is at rest. If you sit in this car, for you the car becomes everything inside the car, the things that are present in the car, the chair and the seats of the car, those appear at rest for you. But is it actually at rest? It's not at rest. For you it is appearing. So that's why we say the term relative comes from here. When you compare it with something, you're comparing it with something, there, that's the point where the relative term comes. Now B observes A. If a person who is sitting in car B, if a person, we have taken the person. So what happens in case of relative velocity? How can you calculate the velocity of car A with respect to B? If you have to calculate, there are two velocities. For the person who is on ground, he is able to see car A with a different velocity. He is able to observe car B with a different velocity. So how will we decide whether the velocity is 10 meter per second for both of them if they are moving simultaneously? What's the velocity that we should choose for which both of them will look similar to each other? Like if you sit in, for a person who is in car B, what is the velocity that it will look for A? Because you are also, just imagine yourself. All right, give me 2 minutes. Start noting down from here. All right, class. So I was discussing relative velocity. Now two cars are moving. A is moving with 10 meter per second. B is moving with 3 meter per second. A person is there on standing on ground. Then the person sees velocity of car A as 10 meter per second, and the person on ground observes the velocity as 3 meter per second. But now imagine yourself. If you people are sitting in car B and car A is moving, so will you be able to see exact velocity with which car is moving? That is, will you be able to observe 10 meter per seconds only? Or you think there will be a variation according to you all? Yes, class. Will there be a variation according to you people, or you think you will see the exact velocity 10 meter per seconds only? What do you think?
Variation will be there.
Variation. You see, variation will be there. Variation, why will the variation be there? Because now you are not static, you are also moving. So that velocity with which you are able to observe while sitting in that car, we call it as the relative velocity. Now, how to calculate relative velocity? In one dimensions, calculation of relative velocity is very easy, believe me. When it comes to two dimension, there you have formulas for time period, shift and drift and all these formulas, shortest time and all. Relative velocity in 1D is very easy. It's simple subtraction, simple addition and simple subtraction, basic simple addition and subtraction. No equations will be formed. But here, understanding the sign convention is important. If you do not consider the sign convention, then your answer will be, every time you will see your answer is coming zero or it's coming double. So that's what I'm saying. Now, what is the velocity that is observed in A with respect to B? We call it as VAB. This is the relative velocity. These were the individual velocities that could be observed as a person sees from the ground. The relative velocity, which we are trying to understand and we are trying to calculate, that is written in this way. This means velocity of A with respect to B. Now, when observer is in B, that's how you write it. Now, if I wanted to calculate velocity of B with respect to A, then how will I write it? I'll write it as VB. This means this is the velocity of B with respect to A. That's how I write it. Velocity of B with respect to A. Now, how to calculate? Calculation is very easy. Sign convention, I'll tell you, remember, vector subtraction we'll use. If it is VAB, we write it as vector A minus vector B. Vectors we'll see in detail right now, because in one dimension you will be just using addition, subtraction, no laws, no rules will be there. So that's why we are not focusing on vectors. After the completion of this, I think 1 or 2 classes will be ending with this. We'll start with vectors, and without vectors all your physics will be unbalanced. So we'll do vectors after this, how to solve vectors if two vectors are there in different angles. Right now, no angle will come to you because it is one dimension. One dimension means in a straight line. We are dealing with motion in a straight line. That's the name of your chapter. Motion in one dimension, motion in a straight line. So here you don't need it, but just for your knowledge, I'm telling you, this is basically vector subtraction. One thing I'll tell you all, I don't know how many of you know this. Vector subtraction doesn't mean that whatever looks in algebraic subtraction is same. For example, if I say 5 minus 3, so all of you will say the answer is 2. So 5 minus 3 is 2 in algebraic addition. But in vector addition or vector subtraction, 5 minus 3 is not, can be 2, 5 minus 3 can be 0, 5 minus 3 can be 2 again, 5 minus 3 can be negative values. Now, how to solve that we'll see in detail. So just for a clarification, I'm telling you, you will soon understand. When we'll do vectors, you will understand why this formula has been directly written. Right now, otherwise, this whole chapter will get paused and we won't be able to complete further. That's why I'm stopping with vectors. Vectors we'll do. Or if it is VBA, Then this is VB minus VA. Vector additions are there. Right now, how to solve vector additions or subtraction? Because here vector subtractions are given and you people don't know vectors. You know how to subtract and add. Just remember the sign conventions, you will be able to put it. Now, sign conventions, how to use sign conventions. Remember, in all these formula, you have to use sign convention. We'll do questions as well on this. How to use sign convention, first understand that. Let's say a car or a ball went in this direction with a velocity, and another car went in this direction. Or let's talk about balls. Another ball went in this direction. This is ball A, this is ball B. I want to calculate velocity of A with respect to B, not the individual or observing velocity from the ground. The relative velocity between them. If both of them are moving and if a person sits on this, then what will the person observe? That velocity. So this will be simply VA minus VB, as I've told you. Now, putting the signs of VA and VB is important. Both of them are in opposite directions. So choose one direction as positive. For example, I choose right as positive. So automatically left for me becomes negative. So this velocity is towards right. So this will be positive. This is towards left. So see, this will be negative. What does it become? VA minus VB. It ultimately becomes VA plus VB. So did you get it? You were subtracting. Now you have subtracted actually. But because of the sign convention thing, your answer came in positive. Let's say both the velocities are, what should have happened? Both the velocities are in opposite direction. They should get subtracted. But because of the sign conventions, if you take one as positive, other as negative, you will get the answer different. Let's say I didn't take right as positive. Let's say I took right as negative. See, if I took right as negative and left as positive, then this VA will become negative. So VAB would have been become what? This have V minus VA minus VB, like this. So obviously VA minus VB means you have to add it with a negative sign. That will show that it is the net movement is along right. Because see, if it is, let's say, -5 -2, this will become this is -5 -2, this will become -7. Or if we look here, this becomes 5 plus 2, that is 7. Both our answers are right, just the signs are different. Now, how to say which answer is right, which answer is wrong? Both are right. This is plus, it means plus is for right, net direction is towards right. Here answer is negative. Here right is negative. It means this is towards right. Did you get it? In all the cases, you are getting the same answer. So sign convention is totally up to you. Did you understand this part or not? Just tell me, all of you, because this is very important for relative velocity. Is that clear? What about others? Clear? Any difficulty in any part for the new students as well? Maha, Fatima.
No.
Yeah, Fatima, what about you? Are you able to understand? Now, another case, let's say if both the bodies are moving in the same direction, this we took, let's say this is moving with 5 meter per second and this is moving with 2 meter per second. So this is A, this is B. Now I am calculating VAB again, let's say. So this becomes what? This is VA minus VB. Now let's say I have taken right as positive and left as negative. So what would the answer be? Right is positive, so this becomes 5 minus. This also becomes positive. So my answer is 3 meter per second. Positive 3 meter per second. It shows net movement is towards right because I have chosen right as positive. Let's take opposite. Let's say right is negative, left is positive. This is the whole, all these are all the possibilities that are possible. Now VAB will be what? VA, this becomes right is negative. So this becomes -5 and this becomes -2. No, this is equal to. See, both of them are in same direction. So in the first case, what did I take? I took right as positive. So what happened? VA was positive and VB was also positive. So this will be 7. This will be 3 only. Next part will be 3. This is this we have done. We were doing this one, yes. So in the second part, I have taken right as negative, left as positive. It means both of them will become negative, negative. So this becomes -5. Minus sign is there for the vector addition, and 2 also becomes -2. So what do I have? I have +2 -5, that is -3 meter per second. So minus is what? Minus is right. Again, the answer here was also right. Here the answer is also right. So did you get it? I've told you all the possibilities. If two objects are moving together, right, left, whatever sign convention you choose. If two objects are moving in opposite direction, right, left, whatever choose. First note down this, then we practice some questions. I'll help you with it, then it will get more clear. Note it down. So here, how will you take the sign convention? Take upwards either as positive, negative, so this downwards will become just corresponding to it. Note down this question, at least try the first and second parts. First and second parts are very easy. Third part I'll help you, but try. All of you try, and once you keep, as you get the answers, keep on sending me. Even third part is also not difficult. But as you get the answer, send me in the chat box. Hey Ramshi, as you're mentioning the answers, no, for one answer you're getting negative, other one as positive like this. So do mention if it is plus something, then what is plus according to you? Because that will tell the direction. Velocity is what? A vector quantity, no? So we need a direction. Magnitude is correct, Maha. Same with you. At least do one thing, all of you. This is north, this is south. Just write this velocity north or that velocity south. And please try this part also, third one. This is a velocity of monkey with respect to A. Uh, Fatima, direction. All Maha answers are right. Aisha answers are right. Fatima, magnitude is right. Specify the direction, north or south in which case. Uh, Aram and Aisha have answered for the third part. Aram, Aisha. Third part is not right. Rest of the parts you've answered well. Let's discuss. Let's discuss. So all the parts, I think magnitude A is north, B is south. Fine, perfect. So all of you have done the first and second parts well. One you took as positive, other you took as negative. Like I think Maha was getting second one as minus 80. Second one as minus 80. So she must have taken downwards as negative. That's why she was getting minus 80 as south. So first and second parts you people have done. I'll write down the solution though. So see, VAB and VBA, these are very simple. First part says VAB. So which means VA minus VB. Let's say upwards, we also take it as positive. North as positive, south as negative. Let's also take the same. So VAB will be what? This will be VA will be 30 minus minus 50. That becomes plus 50. So it becomes 80 kilometer per hour, which is north. Similarly, for the second part, VBA, this will be again VB minus VA. So for here, minus 50 minus 30, that becomes minus 80 kilometer per hour, and this negative sign signifies nothing apart from the direction, that is the south. Now the last part. So till here everyone was able to do. Last part says a monkey is running on the roof of train A. So both the trains are there. Now the velocity that is given to us 5 kilometer per hour. First tell me, is it relative velocity given or is it the absolute velocity given?
Absolute.
See, absolute is when something is respect to ground. Here, the velocity is with respect to passenger A. So two velocities are given which are with respect to something else. So this is not absolute. This is a relative velocity of monkey with passenger A. Let's say velocity of monkey. You have to find out the absolute velocity of monkey. Are you getting it, Aisha? Calculate the velocity of monkey means absolute velocity, that is with respect to ground. Vm you have to find out. Vma is given to you. Did you guys understand this difference first? Yes or no?
Yes.
Yes. So see, velocity of monkey we don't know. We have to find it. Let's say velocity of monkey is Vm. Vma is given to us, that is velocity of monkey with respect to A, means a train A or passenger who is sitting in. So that's velocity of monkey with spelling. So this is a relative velocity given to us. This we have to find out. This is the velocity of monkey with respect to ground. Yes, now it's correct. Aisha, now your answer is right. Monkey with respect to ground. Ground means the absolute velocity with respect to ground. Now see, if monkey is running on the rooftop of train, VMA will be equal to what? how do we write the relative velocity? First one minus second one with which we are calculating the relative velocity. VAB was what? VA minus VB. VBA was what? VB minus VA. So VMA will be what? VM minus VA. VMA we know. VA we know. Only VM is variable to us. See, this question also was not so difficult. It's just that it was given with respect to something that is already known. So VMA. See, both of them are in the same direction. Monkey, which is moving on the rooftop of a moving train, and the moving train, both are in the same direction. So let's take that upwards not as positive, which we have already taken. So VMA will be what? This will be 5 kilometer per hour, and VA will be 30 kilometer per hour. So VM will be equal to VMA plus VA. So this becomes 30 plus 5, which is 35 kilometer per hour. And since answer is coming positive, it means both of them have the same direction. That is not is taken as such. This is how we have to do this part. Just note it down. Send your answers for this question. It says a jet is moving upwards with velocity this much. Then all the burnt fuel or the exhaust that obviously comes in opposite direction. Whose velocity is this with respect to jet? Now you have to find out what's the velocity of those exhaust or fuel burns. Quickly, calculation is very easy. Just try and send. Yes, no. Right answer, correct answer. Others also submit. Fatima, slight error is there in your answer. Check again. And Fatima, as I've told you, do not just simply write the number with the sign. Do mention the SI unit as well as the direction. All right. Now, yes, Aram, your answer was also right. Let's finally discuss it. Like this, you have to mention the direction, a complete answer. So good. It says if a jet is moving, see, a jet is moving. So velocity of this jet is 450 kilometer per hour. All the exhaust is coming in the downwards direction. This velocity is 1200 kilometer per hour, but this is not the absolute velocity given. It means this is not the velocity of the exhaust. This is the velocity of exhaust with respect to the jet. It means is it absolute or relative? Yes, class. Absolute or relative? This 1200.
Relative.
Exactly. This is relative. So let's take upwards as positive and downwards as negative. Let's take this. So velocity of the exhaust. This is with respect to jet is given as 1200 kilometer per hour. It's in the downwards direction. Let's add a negative sign. Velocity of jet is given to us 450 kilometer per hour and it's moving upward, so we'll take it as positive. Now, VEJ will be what? VE minus VJ. That's what we have been studying continuously. V12 will be V1 minus V2. V34 will be V3 minus V4. V43 will be V4 minus V3, like this. So this is known to us, this is known to us, this is unknown. See, put everything here. This is what? This is minus 1200 kilometer per hour. This is VE, which is unknown to us. This is 450. Or this is plus, so this is plus 450. It will move on this side. This becomes 450 minus 1200, which is equal to VE. So VE becomes minus 750 kilometer per hour, and I took it as downwards, so minus shows downwards direction. That's how a complete vector is written in one dimension. All right, so those who did not write, just note it down. We'll do one more question after this. One thing before you start this question, one hint that I'll give you. See, the way we take velocity, no, like VAB, we take it. Just make it a note, point it at in your notes. That becomes VA minus VB if it is relative. Similarly, you have SAB as well for displacement. That becomes displacement of A minus displacement of B. Similarly, you have acceleration also. Acceleration of A with respect to B becomes acceleration of A minus acceleration of B, and so on. Whatever you've studied for velocity, you can apply it for everything. Time is an absolute quantity. Time will not change with respect to anything. So time will be the same. Now use this, use your uniformly accelerated equations motions, use the concept of relative velocity. Now tell me, what will be the time taken by A to cross B? use the equations that you know and then find out the time. Yes, no answers by anyone. Relative velocity, did relative velocity come out by anyone? Relative velocity you could have calculated.
8 meter per second.
How much, Aisha?
8 meter per second.
Exactly, it is 8 meter per second. Now your calculation is very, very easy. See, both of them are in the same direction. So VA will be 10 meter per second, VB will be 2 meter per second. So VAB will be what? VAB will be VA minus VB, that becomes 10 minus 2, which is 8 meter per second. Relative velocity, you people know how to calculate now. You can easily calculate it. This much is done. Velocity is given to you. Now velocity you have calculated 8 meter per second. The relative separation between them, how much both of them are separated with respect to each other, that is given to you as 100. So SAB is given to you as 100 meters. Time will be what? Speed is equal to distance divided by time. So time is equal to distance divided by speed. So time will be equal to 100 divided by 8. So it should be around 12.5 seconds. Yeah, now clear? It was an easy question. You will be able to understand it, I hope. Okay. So this was the last topic of this lesson, motion in a straight line. See, few questions can come from graphs. Acceleration versus time graph will be there. Velocity versus distance graph will be there. So graphs, if I just tell you randomly, no, you'll not be able to understand. So we'll have a full class on graphs first, all the basic graphs that are possible, so that it not only helps you in this chapter, in the upcoming lessons also throughout your physics for even class 12 you are prepared for the graphs. So graph we'll start in the next class only. Graphs topic is left, and then we'll do vectors, because without vectors all of your physics will be difficult. One question I'm giving you, if you people have written it down, a question I'm giving you, that is your assignment. I won't be giving any other assignment today. That question will be your assignment. So it's a request to all of you to at least try that question till whichever step you reach. No, just submit me that. Whichever step you reach. Even if you're just able to calculate the relative velocity, even if you're just able to convert it into SI unit, whatever you get it. The whole question I'll discuss you in the next class. On Monday, I'll discuss it with you before starting with the graphs. But I want you all to try it first. So no assignment will be given to you today. Just do this and see. You have the whole complete weekend now. This was Wednesday today, no? So you have a whole lot of time. So just try it once. Give it a try. Question 4, no? So this is a homework for you. I'm again telling you, see, this is a very famous question that usually comes. Uh, this you can try. A hint that I'll give you. See, on a two-lane road, car A is traveling with a speed of 36 kilometers. So basically, it's like car A is traveling with a speed of 36 kilometer per hour. Now, a car a car B is there, and a car C is there. Both of them have the speed 54 kilometer per hour. All right, in opposite directions means this is towards right, this is towards left. The separation between A and C is 1 kilometer, B and A is 1 kilometer. So as soon as the separation becomes equal, B decides to overtake it, just cross it before C can cross it. It wants to overtake it before C crosses it. So what is the minimum acceleration required by? All right, try this question, and as soon as you note down the question, just text me done in the chat box that yes, you have written it. All right, Fatima done. What about others? Yes, Fatima and other girl, Maha. I want to discuss the timings of backup class. When are you people available? Your vacations must be going on, no, right now? Okay, Ram has done. Because differentiation and integration, at least we should have a class on calculus. When are you available? Okay, Maha has also done. Aisha done? Oh, all right, Aisha. So, Maha and Fatima, are you available this Friday from the same timings?
Yes, ma'am.
What
No,
about you, Fatima? No, you're not available, Fatima.
no.
All right.